So, while you were sleeping last night, and artificial intelligence was out there actively rewriting its own architecture.
Yeah, just completely on its own.
Right. Not just, generating some cold email or answering a history prompt, but running this continuous 5-minute evolutionary loop to fundamentally make itself smarter.
It didn't ask for permission at all.
Exactly. It didn't wait for a human to review the code. It just bred new variations of its own neural network, tested them in the wild, and mercilessly killed off whatever didn't survive the validation test. Okay, let's unpack this. Welcome to today's deep dive.
Glad to be here.
Our mission today is for you, the listener, to really understand this massive recent shift in AI development. And the crazy thing is, it started with this shockingly simple open source GitHub repository.
It really is simple.
Yeah. So just imagine you have this super nerd intern who basically never sleeps. And they're just running these rapid-fire scientific experiments on your code base 24/7, keeping only the absolute best results.
And, the stakes here are incredibly high because we are moving away from the traditional manual feedback loop of AI development. I mean, for years, the main bottleneck in machine learning has been the human researcher.
Right. The human is the slow part.
Exactly. A human writes a script, kicks off a training run, goes to get coffee, comes back hours later to check the loss curve, and then, manually tweaks a parameter before starting all over again.
Which is just so tedious.
It is. What we are looking at now is a framework that takes the human completely out of that tedious, iterative optimization process. It's closing the loop entirely autonomously.
So let's actually break down the mechanics of what this system is doing. The project is called AutoResearch, and it was open sourced by Andrej Karpathy. And looking through our sources, the most surprising detail is just the footprint of this thing.
Oh, it's tiny.
It's like a minimalist, roughly 630-line Python framework.
Which is just remarkably small for something this capable.
Yeah. Mechanically, it's an AI agent that actively opens up and edits PyTorch code. It writes the code, spins up a 5-minute training experiment on the GPU, reads the output logs from that experiment, and then it just attempts to continuously lower its own validation loss.
Right. And it's specifically targeting a metric known as validation bits per byte, or ValBPB.
Wait, let's pause there. Why that specific metric?
Well, to understand why ValB matters, we have to look at what bits per byte actually represents in this context. It's essentially a measure of compression and predictive power.
Right.
So the lower the ValBP, the better the model is at understanding the underlying structure of the data it's looking at. The AutoResearch framework isn't just randomly throwing code at the wall, right?
Right.
It physically manages its own Git feature branch. So it will generate a modification to the PyTorch code, run the training loop, and evaluate that ValBP metric. If the metric improves, the agent actually commits the code to the branch.
And if it fails?
It just discards the change. Yeah, so you end up with this fully documented fossil record of the AI's evolutionary progress. Every single commit message is essentially the AI explaining its own chain of thought regarding why a specific architectural tweak worked.
That is wild. And the real-world proof of this mechanism is staggering. The sources highlight this anecdote from Shopify CEO Tobi Lütke that it completely took over the timeline.
Oh, yeah, everyone was talking about it.
Because he downloaded this AutoResearch script and set it up with just a basic markdown file, prompt.mad. He gave it a starting point, went to bed, and just let it run on a 0.8 billion parameter model.
While he was asleep.
Literally while he was sleeping. Over the course of 8 hours, the AI agent ran 37 distinct experiments, and it managed to improve the model's score by 19%.
Which is huge. A 19% improvement on an established baseline without actually increasing the parameter count is just a massive leap in efficiency.
Right. It pushed that smaller 0.8 billion parameter model to actually outperform a much larger 1.6 billion parameter model.
Just by tweaking the architecture.
Yeah. Lütke even mentioned that reading through the AI's commit logs the next morning taught him more about optimization than he had learned from months of tracking human machine learning researchers.
I mean, it's like having a masterclass generated for you overnight.
But hold on, though. Let me play devil's advocate for you listeners out there. If it's just blindingly chasing a single number on a scoreboard, isn't it just going to overfit?
Right.
I mean, we've seen models p-hack their way to fake success before. If its entire existence revolves around lowering that one ValBPB number, how do we know it's not just memorizing the test data to get a high score without actually getting any smarter at the underlying task.
What's fascinating here is how the framework architecturally guards against that exact vulnerability.
Okay, how so?
Well, the loop validates against an entirely unseen data set. Because the metric is explicitly tied to validation data information the model has never been exposed to during its 5-minute training run, it fundamentally cannot cheat by simply memorizing the answers.
Because it hasn't seen the test yet.
Exactly. To lower the val PB, the AI must uncover generalized patterns. It essentially forces the agent to do honest homework.
Honest homework, I like that.
Yeah, Karpathy essentially built a remarkably clean implementation of recursive optimization. The AI changes its optimizer, it adjusts its hyperparameter scheduling, alters the network architecture, and it only retains the modifications that genuinely increase its capacity to generalize.
And, of course, because it is actively improving its own architecture, the internet reacted exactly how you would expect, which is complete chaos.
Oh, total chaos.
It sparked this wild debate online about the timeline for artificial general intelligence. It forces us to separate the actual reality of this tool from the science fiction hype.
Because anytime an autonomous system starts editing its own source code to improve its cognitive capabilities, people's minds immediately jump to the singularity.
Right.
And Karpathy certainly didn't help cool things down.
He threw gasoline on the fire.
He really did.
He replied to Tobi Lütke's success story with the post that said, quote, "Who knew early singularity could be this fun?" Complete with a smiley face.
The smiley face really sends it over the edge.
It really does.
Yeah.
And the Reddit threads we analyzed, they took that single tweet and constructed an entire worldview around it.
The reaction was just visceral. Users were declaring that the recursive self-improvement loop, the RSI loop, is going to be fully closed by 2027.
People were literally calling this the late singularity.
Yeah.
We saw users mapping out their retirement plans for 2028 because they assume this autonomous optimization loop guarantees an AI economic takeover within 4 years.
Right, but we really need to pull back and look at the balanced counterview provided in the sources, because the skepticism here really grounds the conversation.
Yeah, let's look at that.
Critics from the machine learning community argue heavily that this is nowhere near omnipotent AGI. They point out that AutoResearch is essentially a generative wrapper around existing hyperparameter search tools.
Right, like we've had frameworks like Optuna or Bayesian optimization doing mathematical parameter searches for years.
Exactly. And the skeptics argue that this LLM-driven approach actually has worse sample efficiency than those traditional mathematical methods.
So the argument is that it's just an LLM blindly tweaking learning rates and turning structural knobs. It isn't inventing qualitatively novel neural network architectures from scratch using, profound new mathematics.
Precisely.
Here's where it gets really interesting. It's like an automated evolutionary system. There is a massive difference between a chef tweaking the exact milligrams of salt in a known recipe versus a visionary inventing an entirely new, unprecedented category of food.
That is a great analogy.
The AutoResearch loop is currently just adjusting the salt.
That distinction is crucial, but, this is exactly why both sides of the AGI debate actually have a valid point here.
How so?
Well, is the system primarily executing hyperparameter tuning and minor architectural tweaks right now? Yes. However, human researchers spend an almost incalculable amount of their professional lives doing exactly this.
That's true.
They run a script, adjust the gradient clipping, change the dropout rate, and then they just wait. The AI might not be inventing new paradigms of physics, but it executes these micro-optimizations at a speed that fundamentally accelerates the baseline of all subsequent research.
Because it doesn't need to sleep.
Right. A human might thoroughly design and evaluate 2 or 3 architectural experiments in a day. This autonomous loop runs a completely new evaluated experiment every 5 minutes.
And the compound interest on those tiny 5-minute improvements scales aggressively.
Very aggressively.
Now, if this compound interest on optimizations is so powerful, for you listening, your immediate thought is probably that you need a multi-million-dollar server farm to run it.
Sure, that makes sense.
But since this isn't some magical, omnipotent AGI and rather a highly efficient search loop, its real breakthrough is its incredibly small footprint. This tool's power comes entirely from its accessibility.
This is the democratization aspect, and it really reshapes the entire landscape. Initially, Karpathy was running these AutoResearch loops on an H100 GPU.
Which is not cheap.
No, for context, that is incredibly expensive, enterprise-grade hardware that usually restricts this kind of research to massive tech companies.
But everyday developers are bypassing that hardware entirely.
Yeah.
Creators like Vuk Rosic and the developers at MarkTech Post, they released tutorials demonstrating how anyone can run this continuous loop on a strict budget. You don't need a massive rig. They're deploying this directly onto Google Colab's free computing tiers.
It's amazing.
Rosic even detailed a workflow where he rents smaller consumer-grade GPUs from cloud providers like Novita AI for as little as 18 cents an hour.
18 cents an hour to have a tireless agent researching your architecture?
Yeah, you can't beat that.
And the workflow they map out is remarkably approachable. You clone the AutoResearch repository, but then you make a few strategic patches. You shrink the context length of the models involved, you strictly limit the training time budget, and you scale down the evaluation counts.
So you're just compressing everything.
Exactly. This compresses the entire loop so that it fits comfortably within the memory constraints of a cheap, low-tier GPU.
You run one baseline experiment to establish your starting validation score, and then you just let the loop programmatically edit the train.py file, testing, committing changes continuously.
Right.
But looking closely at the source discussions, a glaring practical limitation kept popping up.
Oh, the amnesia problem.
Yeah. If the agent starts a brand new 5-minute training run from scratch every single time, doesn't it suffer from amnesia? Like, if it tries a bad learning rate at hour 1, how does it know not to try that exact same bad learning rate at hour 7?
If we connect this to the bigger picture, you've just identified the primary bottleneck of early autonomous agents. Out of the box, the baseline agent processes every experiment in a vacuum. It has no continuous memory.
Which seems like a huge waste of compute.
It is, but the speed of the open source community in solving these architectural bottlenecks is unmatched.
Yeah, we found a Reddit user going by the handle Nye2021 who immediately forked the AutoResearch repository to patch this exact flaw.
They moved fast.
They built something they called persistent cognitive memory directly into the loop.
And the mechanism behind this persistent memory is brilliant. The fork utilizes frequency-weighted retrieval.
Okay, what does that mean in plain English?
Think of it like a biological brain strengthening its synapses. Every time the agent runs an experiment, it logs the parameters and the outcome. When it prepares to design the next experiment, it queries this memory bank. Yeah. If a past memory of a specific architectural tweak helped lower the error rate, that memory is assigned a higher weight. The system proactively recalls, oh, I tried reducing the learning rate below this threshold 3 hours ago and the validation score degraded.
So it actually learns from its mistakes over time.
Exactly. Because the retrieval is frequency-weighted, useful constraints are remembered vividly, and the agent actively avoids repeating dead-end experiments. The memories that don't contribute to lowering the loss simply fade away.
So we now have a tireless sub-dollar-an-hour loop. It plans an experiment, acts by writing code, reads the resulting metrics, and updates its persistent memory bank.
That's the core engine.
Right. And once you realize that this plan-atch-read-update cycle is the core engine, it becomes incredibly obvious that this architecture is not restricted to Python code. It is an engine for continuous improvement that can be applied to almost any digital workflow.
The machine learning code is just the first proof of concept. The underlying structure is a universal optimization loop.
Our sources included a fantastic breakdown from entrepreneur Greg Eisenberg exploring the immediate business applications of this framework. He mapped out how to apply the exact AutoResearch concept to everyday operations.
This is where it gets really practical.
Yeah, take marketing, for example. Traditional A/B testing relies on a human creating 2 options and waiting for data. With this loop, you point the agent at your landing pages or ad creatives. The agent continuously writes new headlines, pushes them to a small segment of live traffic, reads the analytics, and autonomously promotes the version that yields the lowest customer acquisition cost. It never stops iterating.
And consider finance operations. A company could deploy an agent to match complex invoices and generate expense reports. Instead of relying on a static set of rules written by an IT department, the agent operates in a continuous auto-research loop.
So it's constantly updating its own rules.
Right. Every time it encounters an exception or makes an error that requires human correction, it rewrites its own operational prompts and rules to ensure that specific error never happens again. It is an accounts payable system that structurally improves its own accuracy every single day.
Eisenberg even envisioned a future for SaaS products where software simply includes an optimize button.
I love that idea.
Just a single button. You install a tool, click that button, and the software spins up a miniature, self-contained auto-research loop tailored entirely to your proprietary data, searching the parameter space to find the perfect configuration for your specific company.
It's brilliant.
But the implications stretch far beyond corporate efficiency. Morgan Linton proposed a deeply provocative application in the medical frontier.
Yeah, Linton's analysis focused on the astronomical costs of clinical trial design.
Clinical trials routinely cost tens, sometimes hundreds of millions of dollars. Linton suggests leveraging this autonomous loop to deploy an agent swarm that optimizes treatment protocols on simulated proxy experiments first.
Before any humans are involved.
Exactly. The Lütke could run thousands of rapid, data-driven simulations regarding patient adherence or biochemical responses. It acts as an evolutionary filter, killing off weak protocols and promoting the most promising candidates.
So you only move to the profoundly expensive human trials after the loop has exhausted the simulated parameter space.
So what does this all mean? For you listening, the paradigm shift is clear. We're moving away from AI as a reactive content generator that helps you write an email. We are moving toward AI as a continuous scientific method vending machine.
A scientific method vending machine.
Yeah, you can point this loop at any painful, data-heavy problem, and it will relentlessly search for the optimal solution while you sleep.
And this fundamentally shifts where human value lies in the workflow.
Right, because if the AI is doing the work,
If the machine is executing the tedious testing, writing the code variations, and iterating through the failures, humans will no longer be the operators. Our job entirely shifts to defining the goal.
we become the architects of the validation metric.
Precisely. The critical human task is ensuring the AI is measuring the correct outcome, because an incredibly efficient optimization loop will achieve its programmed goal flawlessly, regardless of the secondary consequences.
Oh, that's a slightly terrifying thought.
Well, one of the Reddit skeptics from our sources joked that this framework is a highly efficient way of collapsing the economy if we optimize for the wrong metrics.
Great.
And while framed as a joke, the mechanism of alignment is the real warning. When the execution of a task becomes autonomous and near instantaneous, defining the exact parameters of success becomes the only job that matters.
Yeah, be careful what you ask for. To bring this full circle,
Mhm.
Andrej Karpathy's minimal 630-line Python script has pulled back the curtain on a reality that is already here. It's a reality where continuous autonomous optimization isn't locked behind the doors of billion-dollar corporate research labs.
It's out in the open.
It is available to everyone. It's available to the PhD researcher, the everyday learner spinning up a Google Colab instance, and the business owner trying to optimize their customer acquisition cost.
This raises an important question, and it's the specific thought I want to leave everyone with today. Karpathy did not stop with the AutoResearch repository. He recently launched a new project called Agent Hub.
Next step.
He describes Agent Hub as a GitHub specifically for agents. Think about the mechanics of that.
Okay.
There are no human developers involved. There is no traditional main branch managed by a human senior engineer. It is designed as a sprawling network of autonomous commits and a digital message board where a swarm of AI agents coordinate entirely with each other to solve complex problems.
Without us.
Without us. If individual agents can now autonomously research, edit their own code, and optimize their architectures using persistent memory, what happens when they begin collaborating in digital environments where humans aren't even part of the interface?
That is the multi-trillion-dollar question. As you go about your day, think about what specific, painful niche in your own life or workflow could be completely transformed if you had an autonomous 5-minute evolutionary loop relentlessly chipping away at it. Thank you for joining us on this deep dive, because remember, that super nerd intern we talked about at the beginning,
They aren't taking a coffee break.
they aren't clocking out for the weekend. They are running the next experiment right now.